Hello everyone, how are you? You all are doing good. By the way, welcome to my YouTube channel Physics in a Nutshell. As always, if you're just new to this channel, hit the subscribe button, and if you just like my way of teaching, hit the like button. Okay. By the way, after so many days, I'm again making videos because due to some certain reasons, I was not able to make videos. Okay. So, but from now, I'm gonna make again videos continuously. Okay. So today we'll start one more new lesson today. It is actually written here what is the going to be the new lesson today. So basically, we all know now that this is quite summer season. What is going on? And even I am just making video with my fan on, right? Again, if you're now watching my videos, again I know that you are actually having your fan on, right? Sometimes some students may have AC in their home and cooler maybe in their home. With that keeping on, you are just watching my videos, right? So again, if you are just watching my videos at night time, right? Again, if you know now, in my room lights are there, right? That's why so much lightning are there right now because of the lights. So now the question is, why we are so able to use that much of light, to use our fans, right? What are the reason behind this? What actually current comes from? Or if somebody want to ask you, what actually current constitutes, right? With the help of which thing we are getting the current, where we are just getting the power supply, right now. Again, if you are now just discussing with the electricity, that means there's a term that electric current, right? How we can actually control that electric current, right? If your fan is actually continuously moving on, right? With a regulator, we can actually regulate the current. Why it is actually possible? Is there anything that is going to actually resist the motion of the current? All right, and which is the main thing that is going to lead us to the current? So we are going to discuss all these things in this chapter. Okay, so give your 40 to 50 minutes to me, then I will explain how this lesson is going to explain all these things. Okay, by the way, this lesson is quite important for you because in the higher secondary, that is in the class 12, right, the first lesson is going to be based on this lesson. Okay, so now it is your time. You have a good opportunity through this video. You can actually learn some basic things that is actually going to be needed in your future plan, right, in your future time. So it is time that you should actually give your concentration in this video, then you will be able to learn lots of new things. Okay, since we are discussing with the electricity, right, we are discussing about electricity. We are discussing with the electricity. So in physics, there are basically two types of electricity are there. Okay, one is known as what? Static electricity. Okay, one is known as what? Is static electricity, and another one is known as the what? Current electricity. Okay, these are the two types of electricity that we are actually going to get, okay, in the case of the electricity. Now we have to actually understand now what is the meaning of the static electricity and what is the meaning of the current electricity. First we have to understand the meaning of the words. Static means what? Rest. Okay, rest. And electricity means what? Charge. That means we are going to get the static electricity if there is some rest charges are actually present. Okay, this type of electricity is actually present in what? Insulators, right? Okay, you know one experiment that whenever you actually rub your comb in your hair and you just keep that comb and near to some piece of papers, what is going to happen? It is going to attract it in the comb, right? Why? Because it got some positively charged or negatively charged, whatever you say, ions are there, and it is going to attract. Because when you are going to move to the next lesson after this electricity, you are going to get the what? Magnetic effect of electric current. Okay, then you will actually understand that electricity actually generates magnetic field. That's why magnetic field actually can attract, na? So that's why those papers are going to actually attract. Okay, this is the fact, right? Again, what is the current electricity means? Current means what? Motion. Okay, again electricity means what? Charge, right? That means what? Current electricity is that type of electricity where the motion or the charge in usually is going to be in motion. That means when the charge will be in continuous motion, we are going to get the current electricity, and if the charges are in rest, we are going to what? Static electricity. That current electricity is going to be in conductors. Okay, where? Conductors. Okay, now what is conductor and what is insulator? With the help of these two types of electricity, we get two types of materials. One is the insulator, another is the what? Conductors. These are the two materials. Insulators are those things which doesn't actually allow the movement of the charge. Okay, it doesn't allow the charges to move, okay, and it again allows the motion of what? Charge. Right? Why do you actually understand that? Two types of materials we have got, insulator and conductors. Insulator doesn't actually allows the motion of the charge through it. Okay, see, basically insulators are made up of what? Plastic, glass, rubber, these type of materials. So if I consider a comb which is made up of plastic, what actually looks like? It is somewhat looks like this, na? Consider this is a comb and it is made up of plastic. Okay, so what is going to be there? Whenever you actually rub your comb in your hair, what is going to happen? It will attain some charges only in here, in this direction. So there will be charges like that. So whenever you will actually bring this comb near to some piece of papers, okay, some piece of papers are there, it is going to attract. But the fact is, if you try to bring this side to here, tell me one thing, is it going to be attracted? Obviously not, because the charge is only in here, not only here. Okay, so this is the fact. Insulators doesn't allow move the charges through this material. But if you consider a conductor, okay, if you consider a conductor, what is going to happen? If you provide any kind of charges in case of the conductor, what is actually going to happen? The conductor, the charges are going to move like that. That means it will move through the conductor. So if you bring some kind of pieces of papers are there, here or here, it is going to actually attract. Okay, that's how conductors are different from the insulators. Okay, conductors are the good, actually, or you can say conductors are the good instruments which actually allows the flow of not only charges, it actually allows the flow of the heat, current, everything. Okay, that's why it is named conductors, which actually conduct everything. And insulators, through insulators, it cannot actually conduct anything, through which nothing can pass out actually. Okay, that's why whenever you actually use just observe those wires that actually are in your home, inside that wire, okay, the wire somewhat looks like this, na? Okay, inside that wire, it is made up of copper. Okay, that is made up of what? Copper, right? That copper is the what? Good conductor of electricity. But outside layer, okay, outside layer, it is made up of kind of rubber type things or plastic type things, so that when the current actually continuously going through the wire, it doesn't get to give you shock. Okay, because those outer layer is made up of what? Some insulating material. Those outside materials are made up of what? Insulating materials. Those insulating materials doesn't allow the charges to move through it. That's why you can actually hold that actually wire. Right now, this is the main difference between insulators and conductors. Okay, we get what? Till now we have understood two things. That is, one is the electricity having two form of electricity. One is the static electricity, and second one is the what? Current electricity. Static electricity only works in what? Insulators, and the current electricity is going to work only in conductors. Okay. Again, since we are actually discussing with the electricity or electric current, right? It is quite familiar. Now we are actually quite familiar with the one term, that is the water current, right? And air current. Lots of things are actually there. So now the fact is, whenever we actually watch a river, right now, we actually see the waters are continuously flowing. That is known as the current. Current means what? Motion. That means the water is in motion, right? So how that current we are going to get in case of the electricity, right? So do one thing, do one example, or take one example that you take a torch. Okay, you all have torch, right? Torch somewhat look like this, na? This is the torch. Okay, here there is a switch. Okay, so whenever you just switch on the torch, what is going to happen? The light will come out. Once you just hit the switch on, the charges continuously flow, right? Through a battery or through a cell. So what we can actually understand that the circuit may be somehow look like this, na? Okay, there may be a power supply, and it will be one bulb, and this is the thing. And what this switch do? Okay, that switch in actually in case of electricity known as the what? Key. Okay, K-E-Y. K-E-Y. Okay, it somewhat look like this. This means the switch is actually off. Okay, and this means you have actually what? Switch on. That means the key is now closed. Okay, and whenever you go to the higher classes, the key will somewhat look like this. Okay, the key will somewhat look like this in a circuit. You will actually get it in a higher class, but now you have to actually see that the key is actually closed. That means the switch is actually on, right? That's why now current will continuously flow through here and the bulb will actually glow, right? What that key actually did, right? Key make the flow of the charges continuous in a closed path, and that continuous flow of the charges in a closed path known as what? Circuit. Okay, so make it or keep it in mind that whenever you actually discuss with the electricity, you are going to need the term circuit. Okay, circuit, quite important thing. Okay, you are going to need this thing, circuit, because whenever we will actually discuss anything, right, anything like we are going to discuss lots of new things like current, right, and we are going to get the voltage, we are going to get the resistance, all will be connected in the circuit. So that's how circuit actually works. This is a simple circuit. That's actually I am actually showing you. Okay, simple form of circuit. It is actually used in what? Torch. The charges will come here, and if the switch is actually off, the charge will not flow, right? If the switch is actually on, through the power supply, the switch, the light will glow. This is a simple mechanism of the torch light, right? Again, since we are actually discussing with the circuit, let me draw one circuit first. Okay, now I have to draw a completely circuit, right? Here I have considered that switch is actually on, or I have not considered the switch. If there is no switch, consider that the current is continuously going to flow, right? Since the lesson is only based on the electricity, that means we are going to get one Newton, that is the electric current. Now what is electric current? Okay, but before that we have to understand the concept of the charge, right? What is charge? Charge is nothing but it is its inherent property. Okay, see, we all know now that everything is made up of what? Electrons, protons, right? And then there is an atom. Maybe you have got in your maybe class 9 that atom having a nucleus in this center, then around that some cells are there like this, na? Okay, in their cells electrons are continuously moving, right? Like that, electrons are continuously moving, right? Like that, electrons are continuously moving. That nucleus contains proton and neutron. Okay, that proton is positively charged, neutron is the chargeless thing, and that electrons are negatively charged, right? So due to the charge that is actually present in the protons and electrons, they are actually bound to each other. Okay, right? Now no charges present between proton and the electron, the atoms cannot actually construct. If there is no atom, there will be nothing in this universe, right? See, whenever you discussed or you have got in the gravitation in your class 9, you will understand that you have mass, that's why you have gravitational force acting on you, right? If you do not have any kind of masses are there will be no gravitational forces are there, na? So similarly, if there is no charges present in proton and electron, right, so there will be no atoms are there, because there will be no actually bonding between them. If there is no bonding between them, the electrons will be not moving in this circular manner. So this is the charge, and this is the meaning of this charge. Okay, and in universe you are going to get two types of charges. Okay, one is the what? Positive charge, and another is the what? Negative charge. That is positive and negative. Okay, and you need to understand some properties of the charges. What is the property? So the properties are these like charges always repel each other. That means if it is the positive charge, they are always going to repel each other like that. Okay. And unlike charge, if it is the positive charge, if it is the negative charge, it is going to attract each other. Okay, this is the behavior or this is the nature of the charges. Okay, this is the positive charge, this is the negative charge, this is the positive charge, this is the negative charge. Positive or the negative. You can also consider negative. It is again going to repel each other because they are the like charges. It is also negative, it is also negative, it is also positive, it is also positive. So that means like charges always repel each other. Like you can consider magnet. North pole, repel each other. North pole, south pole, attract each other. Similarly, the like charges always going to repel each other, and the unlike charges is going to attract each other. Okay, this is the main thing or the main nature or the main actually what? Characteristic of the charge. And we always actually denote or the SI unit. Okay, if you have to write the SI unit of charge is what? Coulomb. Okay. So why I am just actually giving introduction to you of the charge? Because it is going to be needed. Okay, all thing in electricity is because of the charges. If there is no charge, there will be what? No electricity. And that charge actually comes from one more thing that is going to be needed. I'll just come to that later. Okay, first you should know that what actually charge is. I actually give you some introduction, that is like charges always going to repel each other and the unlike charges always going to what? Attract each other. Okay, we have actually understood the concept of the charge. Now we have to actually understand the concept of the current. Now what is current and how we are going to actually get the current? See, this is a proper definition of the current, that current is actually given by I equal to Q by what? T. Now what does this mean? I have actually given you the definition as a mathematical definition. I stands for current, okay, current, and Q stands for, you know that, charge, and T stands for time. Now we have to write the what? Proper definition. So let me draw one thing, okay. This is a conductor, okay, or you can simply consider a wire, connecting wire, okay. This is connected to a power supply. So consider 1 coulomb charge actually passing through the wire, okay, and through this portion, okay, and this thing is having area A. That means this portion, this hole is having area what? A, okay. If I consider, if with the help of a watch, if I say that 1 coulomb charge is passing through that area in 1 second, okay, then we are going to get one new term, that is known as the what? 1 ampere. Now what is 1 ampere? 1 ampere is the current. That means what we are going to get? We are going to get the current as 1 ampere. That means what? We have to understand that the SI unit of current, okay, let me write down, the SI unit of current is ampere, okay. Name ampere comes after one French scientist or French physicist named as Andre Marie Ampere, okay. After her name, that name actually ampere comes, right? So this is the fact about the ampere. Now if we have to write what is actually 1 ampere is, we have to actually write like that. We have got the 1 ampere is going to be what? 1 coulomb by 1 second, right? So how we have to actually give the definition of the 1 ampere current, right? See, if we have to give the one definition of the current, if there may be a question for you that what is 1 ampere current, so you have to say like that, that if through a conductor 1 coulomb charge is flowing through it in a 1 unit second or 1 second, then you are going to get the what? 1 ampere current. Now see, the fact is we are actually giving some kind of direction in the circuit. Now what is the direction of the current? Okay, to understand it we have to actually be very much actually what? Practical about it, okay. This is a quite interesting question, that what is the direction of the current, right? See, the fact is whenever we connect a power supply to a circuit, okay, this is the negative terminal and this is the positive terminal, okay. We have understand that with the flow of the charges we get the current, right? That means what? There will be direction of the charges too when it is actually flowing in a circuit, right or wrong? Obviously right. Right now again, if there is flow of the charges, if there is a direction of the charges, there will be direction of the current too, right? But the fact is actually the motion of the charges, or the, if you want to say, the direction of the charges is always from the negative terminals to the positive terminals. That means the flow of the charges in this direction, that is the charges actually flowing, or simply if you want to say denominated by the Q, that means Q stands for the charges, right? The charges are flowing in this direction, but the direction of the current is opposite to the direction of the what? Charges. That means charge will flow is in this direction. This is the current. Now quite confusing thing, na? There's a reason behind this, why this actually happened, because the phenomena of current electricity or the movement of the current was observed so many years before the actually discovery of the electron or the charges, okay. Any kind of charge, that is electron, proton, neutron. Neutron is the chargeless thing, so we will not consider that. So we are going to mainly consider positive charge and negative charge. Positive charge comes from the proton and negative charge comes from the electrons, right? So basically what we can say, that current actually observed before the formation of the charges. So what they think at that time, if there is a flow of the current, okay, we will always, they have considered that the charges or the current actually coming from the positive terminal. They don't know why we are getting they are actually getting that current. They later understand that they are actually getting the current because of the flow of the charges, and charges flow from the negative terminal to the positive terminal. But as already they have actually considered the motion of the charges from the motion of the current from the positive terminal to the negative terminal, they actually kept things like that. Okay, there doesn't actually change. But now you have to actually understand now. So it is quite easy to understand. If the current is moving in clockwise direction, right? This is the clockwise direction, na? Always consider that the movement of the current or a movement of the motion of the current or motion of the charges will be in the opposite direction. Okay, it is not, though I said the clockwise direction, it is not like that current is always going to be in a clockwise direction. No, if you just change the terminals, if you draw a figure like that, what is going to happen? Now it is a negative, it is a positive terminal. Now the motion of the current is going to be in this direction, na? And the motion of the charges is going to be in this direction. This is the opposite direction to each other, na? This is the fact actually I am actually telling you. Okay, so this is the fact about the current and these charges. Again, we have actually understood the concept of the current, and we have actually understand that the unit of or the SI unit of current is what? Ampere. Again, there is one instrument named as ammeter, okay, which actually helps us to measure the current. Okay, how much current is actually flowing through a circuit is actually given by one ammeter. You are actually watching one ammeter here, right? This is how actually ammeter looks like. So what it actually do, whenever, again, by the way, that ammeter have to connect in the series, right? See, let me draw properly, okay? Then it will be helpful for you to understand, right? So let me draw it. If it is the circuit, if it is the bulb, here actually the emitter is actually connected. Okay, this is the positive terminal, this is the positive, and this is the negative, so it will be negative. Okay, that's how actually emitters are connected in series. So this is one important thing that we actually understood, that emitters are always connected in series with the circuit. Okay, so that's why emitter actually do. Whenever we actually use one emitter in the series, we are going to get how many or how much current is actually flowing through the circuit. Right? This is the concept about the electric current and the charges. So till now we actually understand the concept of the current, electricity, right? How electric currents are we are going to get, and along with that we have actually understood the concept of the charges, right? We have got one formula, that is actually what is actually the formula is this formula of the current, that is I equal to Q by T, right? Now, so now we are going to understand one concept, right? So that concept is nothing but the what? How that we are going to get the flow of these charges from the negative terminal to the positive terminal. We actually understand na, that charges are always going to flow from the negative terminal to the positive terminal, and in the opposite direction to the charges we are going to get the current. But how, right? How it is possible for the charges to flow from one terminal to the other terminal? How it is actually possible? Now what is the main mechanism there? If you actually ever wondered in the very beginning of this lesson, I have actually given an example of the what? Water current. Or I have actually given one example of the what? River. Now again just take the example of that. So what is really happens in case of a river and a pond? See, two examples take. One is the river and another is the pond, right? So what actually happens in case of a river, that waters are continuously flowing from a certain direction to the other direction. But in case of the pond, what actually happen? The water is continuously static manner or in a rest manner, right? Because why? So if you have some knowledge of the geography, right, or if you have some extra knowledge, you will understand that all rivers are always originated from the mountains, right? Many rivers, I think all of the rivers actually originate from the mountains, right? And mountains are kept always in the high, like high altitude, it is always there, and it always comes from a certain height to the lower height. Now in physics, that concept of the height is actually used with a term known as the what? Potential. Okay, known as what? Potential. Okay, those things which are in very high, very big height, they are going to have a high amount of potential. How? Because there is a relation that which you are going to get in your maybe higher secondary or class 11 or 12. There is V equal to mgh. Okay, which increasing h, V is going to increase. Okay, if this is the mountain, okay, this is the mountain and this is the normal plain area, right? It is having high amount of height, right, mass amount of height, and is having less amount of height. So water will automatically flow like that. Okay, but it is having one potential, it is having another potential. It is having high potential, it is having low potential. So there is difference of potential. So that difference of potential is known as what? Potential difference. Known as what? Potential difference. Okay. That potential difference is important is in here too. The potential difference is the main key thing with the help of which the charges is actually continuously flow in the what circuit. Okay, so here that potential is named as potential, but here this potential will be named as what? Electric potential, right? Electric potential. Now how that potential actually comes in case of this circuit? By this thing. There is a cell or the power supply. Cell gives us two terminals. Okay, that cell that we are going to use in our normal torchlight, it is somewhat look like this now. Two things are there. Okay, one is the positive terminal, one is the negative terminal, right? But the fact is, you may think that yes, positive terminal is going to give us what? High amount of potential, and the low terminals or the negative terminal is going to give us the less amount of potential. But the thing is reversed. That negative side of the terminal is going to have high amount of potential compared to the positive terminal. Because why? We know that charges actually flow from the negative terminals to the positive terminals. Okay, so again from this example you actually understand the concept that if something have to flow from a certain distance to another distance, there should be a potential difference should be there, right? If charges have to flow, okay, from this distance to the from this terminal to this terminal, so what we have to say that it will have high potential difference. That is PD means potential difference, and it is going to have low potential difference. Obviously, na. If there is no potential difference, charge is not going to flow. If charges is flowing from the negative terminal, right, that means what we have to consider? That it is having high potential and it is having low potential because it is actually collecting the potentials or collecting the charges. Okay, if you have high amount of things, then you will be able to give, na. And who will going to consider that those things that we are actually giving? Who doesn't have those things, right? Simple thing of the nature, right? So that's how we can say that the negative terminal is going to have a high amount of potential difference and the positive terminal is going to have the what? Less amount of potential difference. That's how there is what? Potential difference. Not sorry, high potential difference, low potential difference. I should actually say high potential only and low potential only. Okay, not high potential difference, low potential difference. It should have high potential. Okay, it is have low potential. Then the difference between the high potential and the low potential is going to give us the what? Potential difference, right? This is not having high potential difference. It is only high potential. It is only low potential. Okay, so the difference between the high potential and low potential is going to give me the what? Potential difference. And that potential difference in physics or in electricity lesson is going to be denominated by V, capital V. Okay, and that V actually means by, or the SI unit of V is actually in what? Volt. Okay, and that volt names comes after a what? Italian physicist named after Alessandro Volta. What an interesting name, na? Alessandro Volta, right? So after his name, that volt name is actually given, right? Again, we can actually calculate this potential difference with a proper formula. That formula is nothing but what? V equal to W by Q, right? V is for what? Potential difference. Now what is W? W is for work. And we know the charge, that is Q. This is nothing but what? Charge. Now what this actually relation means? What is the physical meaning of this relation? That physical meaning of this relation is nothing but what? The amount of work is done in moving a charge from one terminal to the other terminal is considered as the what? Potential difference. Okay? See, when there is a potential difference, charge have to move, na? From this terminal to this terminal. So if there is moving of the charge, maybe from class 9 concept, you have to understand the definition of the work. Force into displacement, F into D, right? So since the charge is moving, it is having some kind of distance, all right? And when you will go to the class 12, you will understand that between the charges, there is one force. That force is known as the Coulomb force. So we have got what? Force, and we have got the distance. So what we are going to get? We are going to get the obviously what? Work done, right? So that means what? Work is actually keep doing, na? It is in process. So there is continuously working mode is going on, right? That's why with work we got the work, right? And how does actually when we have to do that work? In moving a charge from, or in actually transferring a charge from this terminal to the positive terminal, from the negative terminal to the positive terminal, right? You have to do one work, and whenever you actually divide that work by the charges, you are going to get the what? Potential difference, right? This is the main formula. If we have actually understood the concept that the SI unit of the volt is, or the potential difference is what? Volt. Again, like that 1 ampere current, we have to actually again define 1 volt. 1 volt will be what? 1 joule of work done by 1 coulomb of the charge. So if there is one question that you come in your exam, that what is 1 volt potential difference, what do you have to say? When we have to do 1 joule of work in moving a charge 1 coulomb from one terminal of the cell to the other terminal of the cell, then we will get 1 volt potential difference, right? This is the main meaning, like that. Again, when we are actually discussing like current, we get the ampere. Again, we use one instrument, right? There is known as the what? Ammeter, right? So that ammeter actually gives us the what? Definition of the or the measurement of the what? Current, right? Here, with the help of one more instrument, we can actually calculate that potential difference. That instrument is known as what? Voltmeter. Okay. Now, actually seeing in the figure what is actually how it actually voltmeter looks like. And the main important thing is that like ammeter is actually connected in what? Series. But that voltmeter have to connected in what? Parallelly. That is a parallel connection. You will actually understand in the later part of this lesson what is actually parallel connection, what is in series connection. Okay, so this is the parallel connection. Again, this is a positive terminal, this is a negative terminal. Positive side there will be positive, and negative side it will be negative. So that's how it is actually connected. Okay, this is the main connection formula. It have to be in parallel connection, and it have to be in series connection. Why they have to be connected in, why emitters have to be connected in series, why the voltmeter have to be connected in parallel, you will actually understand in the later part of the lesson. I will actually explain you, but before that we have to actually understand the concept of the one more new thing that is actually going to come the next term. That's without actually understanding that term, you will not able to understand the concept why it is actually connected in series, why it is actually connected in parallel. Okay, till now we actually understand the concept of the what? Potential difference, right? We have understood what? Potential difference that is actually denoted by V. Again, you have to understand the concept of what? Charge, not sources, charge or charge, yes, Q. With the help of this charge, we have got the current, that is the I. Now, okay, we have to actually check how there is going to be the current and how there is going to be the flow of the charges. With the flow of the charges, we are going to get the current, right? Charges will always flow, right? We have to understand that charge will always flow if there is what? Potential difference, that is if there is V. Without the actually presence of that cell, we are not going to get the charge, and if there is no flow of the charge, we are not going to get the current. That means what we can say, there is actually some relation between that potential difference and the current. Now what is that relation? That relationship is actually nothing but V is proportional to I. That means potential difference is directly proportional to the current, or simply, or we can say that current that is actually flowing through a circuit is directly proportional to the potential difference that is actually applied across a circuit. And that relation was actually given by one scientist named as, or one physicist named as, he was a German physicist named as George Simon Ohm. Okay, that's why after his name, the law which actually gives this actually relation is known as what? Ohm's law. Okay, what actually Ohm's law says? It says that, or it states that the potential difference that is actually applied across a circuit is directly proportional to the current, okay, that is actually flowing through the circuit by considering as at a constant temperature. Okay, the temperature have to be constant through the circuit. Then the potential difference is directly proportional to the what? Current, or that current is going to be directly proportional to what? Potential difference. Now why there should be the temperature should be constant, you will actually understand with time. Don't worry about that, you just understand. Just wait. Now look closely that there is a proportionality sign, right? That Ohm's law gives V is proportional to I. Now the fact is we have to remove this proportionality sign. See, whenever we have to actually remove a proportionality sign, we all know that there should be one constant have to be multiplied, right? So given one implies in V, you have to remove this proportional sign. So what we have to do, we have to multiply one constant. That constant is nothing but what? R, right? That R is a proportionality constant. Now what is R, right? That R is a constant for a given metallic wire. Okay, if the current is flowing through a wire which is a conducting metallic wire, that R is going to be specifically that for that wire is going to be constant. See, whenever we have to actually discuss any kind of forces like that, see, whenever in class 9 we get the what? Gravitational force, you write the gravitational force as what? F equals G m1 m2 by r square. That G was what? Universal constant. That means that G is going to be constant in whole universe. But here that R is not going to be constant everywhere. It is going to be changed where the material is going to be changed. If it is a copper wire, it is going to be different. If it is some aluminum, if some other materials or other alloys, it is going to be different. So it is specifically constant for a specific material, right? So here R is known as the what? Resistance, and it is constant for a given material at a given temperature, right? So this is the fact about this thing, and that whole relation is known as what? Ohm's law. It is V equal to IR. So if we draw a graph, okay, between potential difference and the current, right? Here we have to consider the potential difference, and here we have to consider the what? Current. There is a proportional sign is given between V and I. What that actually means, proportional sign? That means with how I is going to change, P is going to change accordingly. That means if I come across 1 ampere, it is in ampere, it is in actually volt. So if I come across 1 ampere, it will again change, going to change 1 ampere. Again, if I come across 2 ampere, it is going to come 2 ampere. Again, going to 3 ampere, it is again going to get 3 volt. So if you draw a line that will actually pass through this, that is going to get a straight line, which is actually going to pass through the origin, right? This is the main thing about the what? Proportionality sign. Any graph, okay, or anything, any relation which is in proportionality symbol, which always look like this, right? So with a proportional sign, it cannot be look like that. It is 1, then it is going to be 3. It is 2, then it is going to be 5. No, if it is going to change by 1, it is also going to be changed by 1, right? Or maybe 10, 20, like that. 1 with 10, 2 with 20, 3 with 30 is again going to be. It is have to be in proper ratio, with proper proportion, like that. Okay, this is the concept about the what? Ohm's law, right? Now, from here we can say something now, that I is going to different, right? Or I is going to differ. That current is going to be differ with the two quantities. That is, if I have to write I, that is current from here, is going to be what? P by R, right? We have got the current is equal to P by R. So if we have to actually understand this, I have to explain something, right? See, this is the main circuit thing, right? This is the current. So again, I have to add one resistance. That resistance is going to look like somewhat look like this. Okay, the resistance have a actually what sign like that. Okay, this is the sign of the what? Resistance. So this is the resistance. Okay, so if I consider that resistance is constant, that is 10 ohm. High resistance, 10 ohm is the quite high resistance, but I am actually considering, right? We can consider anything. So this is the 10 ohm resistance. Okay, I have considered that this is the constant thing. So if it is constant, so what you can write from here, that I is proportional to V. R is the constant, na? So I can write this I is proportional to V. That means I is directly going to proportional with the what? Potential difference. That is same law, right? Again, reversely, if I consider that the potential difference is what? 100 volt. I keep the thing constant. So now from here, what I can write? I is inversely proportional to R. So if that means what we can say, if I keep the potential difference constant, I keep changing the resistance. First I consider 10 ohm, then I consider 20 ohm, then I again consider 5 ohm, 2 ohm, different resistance are there. So according to that, with keeping the potential difference constant, we are going to get the current different because it is inversely proportional to the resistance. That means what we can say? We can say that with R increasing, I is going to decrease. With R decreasing, I is going to increase. Simple fact. If you want to understand simply, see, if you're just moving in a road, okay, this is you, okay, and there are lots of people are there, lots of people are there standing in front of you. It will be difficult for you to move through like that, okay. Those will act as a resistance, right? Again, if there is only one people or one person are there, it will be quite easy for you to move. Like traffic, if there is high traffic in a road, it will be little difficult for you to move through it quite smoothly, right? Those traffic will act as a what? Resistance. Here the resistance is nothing but what? Traffic of what? Atoms. Okay. When there is a flow of the charges, they will not going to move freely. Though they are free charges or they are free electrons, right? So they are not going to move as freely as possible, because there will be what? Presence of the atoms. They are going to collide with the atoms. Like, see, let me explain very properly with a proper diagram. See, if it is the conducting wire, okay, charge will flow from this direction, like charges are actually continuously flowing, but there will be what? Atoms are actually present, na? Like that, atoms are having big size compared to the free charges. So what is actually going to happen? The atoms are, the electrons are, or the charges are going to collide with this here, like that. Some will repel here, again some will consider that, collide with here, again it will collide with here, again they will move, again they will going to collide here, right? Again it will collide here. So this collision with the atoms that is actually present in the what? Conductor is nothing but the what? Resistance. Okay, similar thing happens in the road when we actually move, right? If there is high amount of traffic, we have to actually slow down our motion, right? So if there is resistance, that is, which is actually inversely proportional to the what? Current. If the resistance increases, current is going to decrease. If the resistance decrease, I is going to increase, right? Like that. It's a simple fact. Okay, this is the whole concept about the what? Resistance. Again, like current, which is actually measured by what? Ammeter. Like potential difference, which is actually measured by what? Voltmeter. Like that resistance can also be measured with an instrument named as what? Ohm meter. Okay, ohm meter gives the reading of the resistance, how much resistance you are actually getting, right? That ohm meter is somewhat look like this that we are observing in the diagram, right? Again, there is one more instrument named as what? Rheostat. Okay, that physical sign of that rheostat is somewhat look like this. You can give like that or like that. These two symbols actually dedicates the meaning of the rheostat. What the rheostat actually do? You can actually consider the value of the resistance with the help of the what? Rheostat. By moving the coil in the rheostat, we can actually consider the concept, or consider actually how much resistance you want to apply with the help of that rheostat. Okay, this is the resistor do. Now the fact is, what is the difference between conductor and insulator with the, or based on the base of that resistance? See, there is now no that kind of thing which is doesn't going to apply resistance. Okay, conductors is also going to have a resistance, but in a appreciable manner or in a appreciable amount. Okay, see, one thing you have to understand very deeply or very properly, that resistance is necessary. Okay, if there is no resistance, the cell will get damaged, the circuit is going to be damaged. See, what is going to happen? If there is no resistance, there will be no resilient movement, right? There will be no actually constraint movement, there will be no constraint. See, in a circuit, that what resistance do? It actually prohibits the motion of the charges, or motion of the what? Electrons, or motion of the protons, whatever you want to say. See, if there is no actually resistance there, what is going to happen? The current which is actually coming from this positive terminal is going to get in a negative terminal. So that means what? There will be possibility that the cell will get damaged or the circuit is going to be damaged. What resistance do? It actually keeps the thing properly, right? That bulb is going to get less amount of current which is really coming from here with the help of that resistance, right? See, what we have got? Current is going to decrease with the R, right now. So if there is no resistance, this term will vanish. Only what will be there? P is proportional to I. If I apply 100 volt, we are going to get 100 ampere current. So what is going to be there? So the cell will get damaged, or the whole circuit will get damaged, the bulb will get damaged, the emitter will get damaged, that actually voltmeter will going to get damaged if there is no resistance. If you attach one resistance there, what is going to happen? If we apply one resistance, consider 20 ohm. Okay, that value will decrease by what? 5 ampere. 5 ampere current we are going to get, right? So this is the fact. That's how actually resistance helps. So that conductor is also going to have a resistance, but in a decent amount. Okay, required amount. But in case of the insulator, why it is actually having no flow of the charges through it? Because it is having infinite amount of resistance. Okay, infinite. Okay, so that the charges are not actually flowing through it. It is not actually possible for that charge to move through that actually resistance. Okay, this is the fact, or this is the main thing about the what? Resistance. Again, one thing that actually give you the resistance, the component which is going to actually give you the resistance, that one is what? Resistor. That resistor is the thing that is actually going to give you the what? Resistance, right? Again, there is certain thing that you actually understand. Till now, what I actually understand, that current is going to depend on both potential difference and the R, but that R actually depends on more other terms. If that R is going to depend on that terms as a whole, or as a indirectly that I is going to depend on that terms. Now where that resistance is going to depend, we have to actually understand. Now let me explain. Now we have to actually understand in which factors resistance are going to actually depend. In your NCERT book, lots of things are actually written about that thing, or about that the factors on which the resistance is going to depend, but I will explain very simply to you, okay? That's so that you can actually understand quite simply, right? To understand it, let me actually give you one example. With an example that you are going to actually understand properly, okay? Consider yourself as a resistance, and you are just moving in a car, okay? This is a car and you are just moving, and you are what? A resistance, okay? You have to move from A position to what? B position, okay? So this is the length of the path, that is what? L, okay? If L is quite high, that means if you have to move from A to B which is having a 500 kilometers, okay, distance between A and B, that means what? You are going to take high amount of time in moving from A to B. That means what we can say? With L, R is going to increase, right? Now this is directly proportional, right? So what we can say? R is directly proportional to L. That means as L increases, it will take more time, right? So the R will increase. So that means what? You have to take time to reach from A to B. So what you can say? R is directly proportional to L. Again, if I consider one more road, which is quite broad, okay, this is one road. Again, this is the position A to B, right? Here what actually happened? The road becomes quite big, quite free road. No traffics are there, right? Right? So if that road is like that, and it will have a area, right? A, right? So consider yourself moving in a path which is quite big, and there is less amount of traffic are there. It is not going to actually bother your motion or bother the motion of the car, right? So what we can say that from here, that with the increase of the area, resistance is going to decrease. So what you can say from here? R is inversely proportional to 1 by A, that is inversely proportional to area. So if I consider these two or combine these two things, what we are going to get? R is proportional to L by A. Again, there is one proportionality sign. We have to actually remove it. So with which quantity we are going to remove? That quantity is known as what? R is equal to rho L by A, right? We have got the relation R equal to rho by A, rho L by A. That term is known as what? Rho, okay? That rho is known as what? Resistivity. That rho is known as what? Resistivity. And resistivity is the characteristic property of the material. That resistivity is constant, like resistance is constant for a given material, like that resistivity is also constant for a given material. Like for what? Metals is going to be different, for alloys it is going to be different, and for what? Insulator is going to be different. It is high in case of the insulators, okay? And in case of the conductors, it have a range of 10 to the power minus 8 to 10 to the power minus of 6 ohm meter. Again, ohm meter is the SI unit of rho. That is SI unit of rho is ohm meter, okay? Again, in case of the insulators, it have a range of, it is the case of the conductor, or in case of the insulator, okay, in case of the insulator, it will have a range of 10 to the power 12 to 10 to the power 17 or 16, maybe as like that ohm meter, okay? Now the fact is, you may ask me, sir, how we are going to get the SI unit of rho is ohm meter? Let me deduce it, okay? We get the relation as R equal to what? Rho L by A. We need the unit of the rho, so I will move that L by A to the left side. So what is going to be there? R A by L equal to rho. So what is the unit of the R? Ohm. What is the unit of area? If you consider in meters, it is going to be what? Meter into meter. And what is the length of the L? So what is the unit of the L? Meter. So meter and meter get cancelled. So what we are going to get? Rho equal to ohm meter. So this is the thing. There may be one question comes, so that the SI unit of rho is ohm meter. So you have to do like that. So write it down in your copy. Okay. So this is the concept about the resistivity. But again, resistivity plays an important role, right? See, whenever we have to use that iron, right, that geyser, that any kind of heating coil, we always use those materials which is having higher amount of resistivity, but they have to be conductors. conductors with high amount of resistivity. That is actually used nothing but what? Alloys. Alloys is a mixture of conducting and some kind of semiconducting materials are there. So they behave as a conductor, but they are having high resistivity. But proper conductors are having low resistivity, so we can't use them. So we have to use those kind of materials which are having high amount of temperature or high capability to take temperature, right? See, heating coils have to get what? High amount of temperature, so that material should have that much of capability to take the temperature, right? So that's why we use alloys. In case of the what? Iron materials, lots of like that. Again, in case of the bulbs, some bulbs, tungsten filaments are used. Why is that tungsten filament? Because tungsten filaments are high melting point, so it doesn't actually get burned easily, right? That's why I use tungsten, right? It is having high resistivity too, right? And again, in case of the alloys, it is a high resistivity. With high resistivity, it can actually make the whole circuit so much easy to consider that amount of temperature, right? So this is the main concept of the resistivity. What resistivity actually do? Resistivity gives the characteristic property of the material, right? How much resistance it can actually consider, right? Resistivity, right? Again, when you will get to the actually higher classes, you are going to get the concept of permeability, permittivity, lots of concepts are there. There are actually lots of different things, but resistivity gives us the information about the material, how much resistance it is actually going to provide, or how much temperature it is actually going to going to consider. Simply, if you want to say high resistivity is going to be high amount of temperature actually considering, but in case of the insulator is going to be different. I'm just considering the say alloy and metal conductors. But see, if you consider that, yes, sir said that high amount of resistivity is going to have high amount of temperature, but if you boil one if you just take one plastic, it is also insulator. If you just keep that plastic to a fire, it is going to be melt. But in case of the high amount of alloys, some amount of alloys and some amount of metals, they doesn't actually get actually melt easily, because though they have actually high amount of resistance or high amount of resistivity. This is the characteristic property of the material raw, right? So this is the main concept about the resistivity, right? So in this class, we have to understand lots of things about the electricity, starting from the source, current, then emitter, voltmeter, what is the potential difference, what is electric potential. We have actually understood lots of things. So it is actually beneficial for you if you just watch the videos properly. Don't skip it. Otherwise, you are going to get problem, or you are going to get in trouble in the class 12, right? Because in the first lesson is going to be based on this electricity. Your first lesson in the class 12. So those students who are actually interested in taking science, you have to take it seriously, this lesson. And what I have said in this video, it is quite important for you. So don't take it lightly and watch the videos properly. Okay? Do watch the video properly, and if you have any kind of doubts are there, just ask me. I am always there. Okay, if you think that I have not explained something properly, just tell me again. I will again explain, right? I'm here for you right now, so tell me. Okay.